Welcome back. It is Monday, April 20th, and we are going to start looking at properties of logarithms. So this is a little bit review. These are some properties, but we have some review going on. If the bases are the same, remember they cancel out and your answer is whatever is left. Same with your base of your exponential to the log with base b. If those bases are the same, your answer is going to be that x value right there. So let's go through this again. Log base 2 of 2 to the 7th. What's our answer going to be? Our answer is going to be 7. Same, if my bases are the same here for my exponent and my log, then my answer is going to be 3. So yeah, I know we already did this last week, but just a little refresher. On this one, my base is 10 and I just have a log. Well, if there's not a base there, you know it's a 10. And so my answer is going to be 6x on this one. Natural log, remember that is just log base e of e to the x minus 1. My bases are the same, so my answer is going to be x minus 1. On this next one, we can make our bases be the same. And when we make our bases be the same, I'm going to have log base 3. Can I make 3 to some power 27? Well, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. What do we do here when I have an exponent to an exponent? We multiply, so that's log base 3 of 3 to the 6th power. My bases are the same, so my answer is 6. And last but not least, log base 5, can I make this 5 to some power? 5 to the first is 5, 5 to the second is 25, 5 to the third is 125, and 5 to the fourth power is 625. My bases are the same, so my answer would be 4. Okay, that's review. Now we're going to get into our product property, quotient property, and power property. If you need to, press pause to write these down for notes. Okay, we're back. And what this is telling us is if I have, for the product property, log base b of m times n, I can separate those. I can expand it to be log base b of m plus log base b of n. So let's do a quick problem. How about log base 2 of 2x? I can expand that to be log base 2 of 2 plus log base 2 of x. Okay? And then you could actually reduce that, because if I have a number, what's log base 2 of 2? 2 to what power is 2? That would be 1. So my answer would be 1 plus log base 2 of x. All right, quotient property. Quotient property, here we go. If I am dividing, I can expand my log to be a subtraction. So multiplication is addition. Division is going to be subtraction. So let's say I have log base 3 of x over 5. To expand this, that'd be log base 3 of x, my numerator, minus log base 3 of 5. 3 to what power is 5? We don't know, so we can just leave our answer as is. And then last but not least, we have the power. Let's see, what do I want to use? Let's go orange. The power property. If I have log base b of m to the n, all I have to do is take that exponent out to the front. So it's n times log base b of m. For example, log base 5 of x to the 7th. To expand this, I'm going to take this exponent out to the front. So that's going to give us log base 5 of x, and what comes out in front? That's 7. So 7 log base 5 of x. So note, there is no property for when you're adding or subtracting. No property. So we're going to use these. Make sure you have them written down. If you need to, pause to get them written down. Okay, here we go. So what we're going to do is we're going to find the following. They have given us logs and their approximations. We just have to figure out how to use it. So log base 2 of 7 is approximately 2.807. Log base 2 of 21 is approximately 4.392. How in the world can we get log base 2 of 3? Well, what we're going to use are these numbers here. How can I use 7 and 21 to get me a 3? Well, 21 divided by 7 gives me 3. So if I divide to get those, that means I can subtract. I'm going to have to use log base 2 of 21 first. So this is going to be log base 2 of 21 over 7. That gives us our 3. So we have to expand this. So that's going to be log base 2 of 21 minus, because we're dividing, log base 2 of 7. And here's where we write in the values. Log base 2 of 21 is 4.392 minus log base 2 of 7 is 2.807. And we're about to get our answer by subtracting those. So 4.392 minus 2.807 gives us 1.585 as our answer. So we just use what they gave us and our properties to find our answer. Let's go on with the next one. Here we go. So we have log base 3 of 8 equals this. Log base 3 of 4 equals that. Somehow I'm going to have to get the value of 32. Well, 8 times 4 gives us 32. So log base 3 of 8 times 4. And I know because of my property, I'm going to add them. Log base 3 of 8 plus log base 3 of 4. Now we write in our handy dandy numbers that they gave us. We get 1.893 plus 1.262. When I add those together, 1.262, I get the answer 3.155. So log base 3 of 32 should turn out to be 3.155. How are we doing? All right, going on. What we're going to do is we are going to create a single logarithm. Single logarithm. So we have to look if we're adding means multiply, right? Adding means multiply. So this is going to give me log base 4 of 2 times 32. And I can multiply those together. Log base 4 of 64. I can change that to be log base 4 is 4 to some power 64. 4 to the first is 4, 4 to the second is 16, 4 to the third is 64. Since my bases are the same, my answer turns out to be 3. That's why we did the little review at the beginning. Let's look at this next one. If we are subtracting, what does that mean? That means that we're going to divide. So we have log base 3 of 972 divided by 4, since we're subtracting. That gives me log base 3, 972 divided by 4 is 243. Now, let's see if we can make those the same base. So log base 3 of 3 to some power is going to give me 243. So 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81, 3 to the fifth is 243. So since my bases are the same, 5 is my answer. All right. Now we're going to expand. That means we are going to make this into several logarithms with adding and subtracting in between them. So the first thing I always do is I always count how many logs do I need. Well, I have an x, that's 1. I have a z, that's 2. And I have a y, that's 3. So I'm going to have log base 2, log base 2, and log base 2. Now, whatever is in the numerator, we're going to add. So x squared plus z cubed, because those two are being multiplied and they are in the numerator. Next, I have y, but where is y located? If it's located in the denominator, you are going to subtract. If it's located in the denominator, you're going to subtract. Now you think, oh, I'm finished, but no. The next thing we have to do is we have to pull these exponents to the front. Pull the exponents to the front. So my answer in the end is going to be 2 log base 2 of x plus 3 log base 2 of z minus y did not have an exponent except for 1, so we're just going to write it exactly as we see it, log base 2 of y. And we just expanded that into 3 logarithms. Not too bad. Let's try another. Okay. We have natural log, and the first thing we do is we are going to count. I have a 1, a 2, and a 3. So I'm going to have the natural log, the natural log, and the natural log. Next, I'm going to put the values. So I have z here. What is the cube root of x? Is there any way I could write that with an exponent? Well, that's going to be x to the 1/3. Remember, the index always goes in the denominator. So I'm going to use that, x to the 1/3. And then we have the square root of y, I need to write that with an exponent. Remember, square root has an invisible 2 there. That value goes to the denominator, so it's actually y to the 1/2. Okay. Are we multiplying these or are we dividing? Well, we are multiplying, so what sign are we going to use between the natural logs? It's going to be addition. Okay. Next, we take our exponents to the front. Exponent to the front. Now there's 2 ways that you can see this written. I want you to see both of them, just in case on big ideas they give you one way or the other, or both ways you need to know. So I have the natural log of z plus 1/3 the natural log of x plus 1/2 the natural log of y. Or this can be written as the natural log of z plus, since I'm multiplying by 1/3, that means I'm going to have the natural log of x all over 3. Those mean the same thing. Plus, I'm multiplying by 1/2, that means my 2 is in the denominator. And there's our answers. These are both correct answers. You just need to see the different forms that they may be written in. All right, here we go. Our next one. On this one, we have a number and we still need to count that. So I have 1, 2, 3, 4. 4 logs. Whatever's in the numerator is being multiplied and they have addition signs. So I have log of 100 plus log of x to the 4th. Anything that is in the denominator, because it's in the denominator, is going to have a minus sign. So minus log y minus log z to the 2nd power. Even though my y and my z squared are multiplied in the denominator, since they are in the denominator, they have minus signs in front of them. Now, all we have to do is bring forward those exponents. And if we have a number, see if we can actually find the log of that. Well, if it doesn't have a base, you know it's a 10. 10 to what power gives me 100? And your answer should be 2. 10 squared is 100. So you should get 2 plus, bring your 4 to the front, 4 log of x minus log of y minus 2 log of z. And that right there is your answer. Okay. Your assignment is in Big Ideas 6.5a, and I can't stress enough, please contact your teacher if you are having any questions. Ask your teacher. That's why we are here. Ask your teacher if you are needing any type of help.